we know more about space than we do about the ocean. We know more about the ocean than we do about the Earth's core. But how do we study something that lies more than 1,000 miles beneath our feet? Oddly enough, you need to fly into space. Thanks to satellites orbiting the planet, scientists have discovered something strange at the very heart of the planet. News about mysterious signals from space barely surprises anyone, but how about this? We detected strange signals coming from deep beneath our own home. Before we go into those signals, we need to understand why it's so important to study what's inside the planet. How does the core affect us? Our lives depend on it in several crucial ways. First, the core plays a fundamental role in gravity. We don't drift off into space because a massive spherical mass of molten metal locks us to the surface. Second, it powers Earth's magnetic field. Dangerous cosmic radiation and solar wind that could scorch everything are blocked thanks to the planet's magnetic field. And third, the inner processes of the Earth influence earthquakes and volcanic eruptions. Any disturbance inside the core and mantle can change life on the planet. And recently, scientists recorded something unusual coming from down there. At the beginning of this century, the United States and Germany launched a mission called GRACE, the Gravity Recovery and Climate Experiment. At first, this project used 2 satellites to track how water moved around the planet and how glaciers were melting. But the satellites could also measure Earth's gravitational field. If gravity was slightly stronger or weaker in some region, one of the satellites would be pulled toward that spot, and the other would measure the change in distance. In very simple terms, the heavier something is, the stronger its gravitational pull. In certain parts of the planet, gravity can be slightly higher because of large geological shifts, ocean currents, or melting ice. But between 2006 and 2008, the GRACE satellites detected a strange change in gravity along the coast of Africa. Melting ice, water movement, and other natural phenomena couldn't explain the anomaly. No one knew what it was at the time, but years later, scientists suggested that the nature of this signal was coming from the Earth's core. Researchers noticed that some minerals, like perovskite, can undergo a phase transition when exposed to enormous pressure and extreme heat. And there are many perovskites lying in the upper layers of the mantle. When the internal structure of this mineral reshapes, it becomes denser and shifts the surrounding rocks. Deep underground, this harder, solid part moves the softer molten rock. These movements reach the molten outer core and slightly deform it. This deformation inside the core alters the flow of molten iron, and this deep current of liquid metal directly affects Earth's magnetic field. That's why satellites recorded those fluctuations. So how does all of this affect us? We launch satellites, we use compasses, we rely on GPS. All of this works only because gravity and the magnetic field are stable, and both depend on the core. That's why it's so important to study the Earth's heart. And to do that, we don't need to dig thousands of miles. Movements on the surface can reveal what is happening inside. Studying vibrations in the crust, recording gravitational shifts, calculating, modeling, and forming hypotheses. It all sounds a little boring. Is there another way to figure out what's happening down there? We sent Voyagers into space, and some of them have already left the solar system. We descend into the depths of the Mariana Trench inside bathyskiffs. So what's the problem with drilling a shaft deep into the Earth's crust? Humanity actually has some experience with this. In the 1970s, Soviet geologists began drilling the Kola Super Deep borehole. It became and remains the deepest artificial borehole ever created. Its depth reaches 7.6 miles, deeper than the Mariana Trench and higher than Mount Everest. More than 50 years have passed, and humanity has not gone deeper than 7.6 miles. And do you know where the Earth's core begins? At about 1,800 miles down. That's almost 7 times farther than the distance to the International Space Station. To reach the core, we would need to drill a hole 230 times deeper than the Kola Super Deep. But that project was shut down in 1992, and the borehole was closed in 2005. What stopped us from digging deeper? First, the density of the rock. In the early stages, the drill easily cut through granite, but around 4.3 miles down, the rock became much harder. The drill broke several times. Workers had to change the drilling direction to pass through softer layers. Eventually, the borehole's shape looked like a string of lights hanging on a Christmas tree. Another problem was heat. The deeper the engineers went, the hotter it became. Scientists expected that past a depth of 10,000 feet, the temperature would be around 212 degrees Fahrenheit. In reality, the harder they worked, the worse it got. Eventually, it reached 356 degrees Fahrenheit. The hottest place on Earth is the Sonoran Desert along the Mexican-US border. Temperatures there can reach 177 degrees Fahrenheit. That's twice as cool as inside that terrifying borehole. And the challenges did not stop there. At a depth of about 14,800 feet, the rock became porous. The extreme heat gave it a strange plasticity. Instead of solid stone, the drill had to cut through something more like hot, softened material that was almost impossible to drill. On top of that, the stability of the shaft became a danger. At such depths, the walls could collapse at any moment. To drill deeper, humanity would need completely new technology, a drill capable of working at 500 degrees Fahrenheit. That is the temperature scientists expect in the upper mantle, located just beneath the crust. And to reach it, we would need to drill 25 miles down, almost 3 times deeper than the Kola Super Deep. There are many rumors about what the engineers supposedly discovered in that hole. The most popular claim is that they heard the screams of thousands of people who were stuck in the fiery underworld. Other fake stories claim that the workers went insane after seeing something horrific at the bottom, and that's why the project was stopped. But if we ignore these myths, what did scientists actually find? They learned that the existing temperature model of Earth's interior was wrong. It was far hotter down there than expected. Geologists thought they would find the so-called Conrad discontinuity, a transition from granite to basalt. They found no such boundary. The real discovery was a liquid at incredible depths. Scientists found cracks filled with briny water. This changed our understanding of the crust. People used to believe it was completely solid, but now it appears full of fractures and channels through which water can move. Where did it come from? Geologists think the fluid was squeezed out of the rocks by enormous pressure, as water is wrung out of a sponge. But the most astonishing discovery was life. At about 4.5 miles down, engineers found ancient fossils of single-celled marine organisms. They were nearly 2 billion years old, and they had survived at such extreme heat and pressure. Let's imagine that one day we actually reach the mantle. What would that give us? What would we expect to see? We would finally understand how Earth formed billions of years ago, how the core, mantle, and crust developed, and how plate tectonics works. We'd know how the plates push and pull against each other. We'd gain a deeper understanding of earthquakes. Researchers also hope to find extremophiles. These are primitive organisms that can withstand extreme heat and pressure. If we discover life near the mantle or even within it, scientists will study it closely and try to understand how it manages to survive under such brutal conditions. If we learn what keeps life alive in the most hostile environment beneath our feet, we might learn how to protect life in other extreme places. From the depths of the ocean to distant planets, studying the heart of our planet could reveal technologies we can barely imagine today. Our future might depend on the mysteries hidden beneath our own world.
Deep inside our planet, there are 2 massive blobs of rock that have puzzled scientists for years. They sit deep inside, opposite each other. One lurks under the Pacific Ocean, the other under Africa. And they're so weird, they even make seismic waves slow down. Their actual name is large low-velocity provinces, but they're just two enormous, mysterious blobs of rock, bigger than continents, stranger than anything else inside the Earth, and so dense they might be leftovers from another planet. Until recently, no one knew what they were, where they came from, or why they even exist. These mysterious blobs could hold the secret to Earth's deepest forces, powerful enough to shape earthquakes, drive volcanic eruptions, and even influence the evolution of life itself. And now, we might finally learn the truth about them. These geological monsters are hidden about 1,800 miles beneath the surface. Each one is 100 times taller than Mount Everest, so vast they defy explanation. Now, at first, scientists thought these were primordial remnants from Earth's early days. Maybe something giant smashed into Earth about 4.5 billion years ago, and this impact formed both the Moon and these blobs. Scientists believe it could have been a planet named Theia, a Mars-sized planet that existed somewhere around the asteroid belt and slammed into Earth back in the day. Others believe it could be something much more familiar, old chunks of Earth's crust. Perhaps they got pushed deep into the mantle by the movement of tectonic plates. And now, a new study shows that these blobs are massive piles of oceanic crust that have been sinking into the Earth for billions of years. They could have formed from the stuff that sinks into Earth when tectonic plates collide. Over 1 billion years, pieces of ocean crust could have been swallowed by the mantle. Eventually, they collected into two massive regions deep inside the planet. But even though both blobs form the same way, they aren't identical. There's this place called the Pacific Ring of Fire, a giant loop of volcanoes and earthquake zones around the Pacific Ocean. Well, the Pacific blob doesn't just stop growing and changing because it's constantly being fed fresh rock from that place. Tectonic plates crash into each other, and one plate sinks beneath another, pushing old ocean crust deep into the Earth. Since this keeps happening, the Pacific blob is heavier, denser, and more active than its twin under Africa. It's like a giant hot rock factory, constantly getting new material and reshaping itself over time. The African blob is much older and quieter than the one under the Pacific. It doesn't get fresh rock pushed into it as often. That's why, over time, it has blended more with the surrounding mantle. Since it's less dense, it behaves differently. It rises higher into the Earth's mantle, stretching 340 miles closer to the surface. And that might be why Africa has so many powerful volcanoes and rift valleys today. The biggest question is, how do they keep evolving? Scientists think that huge columns of hot rock, called mantle plumes, might be pushing up from deep inside the Earth, helping to drive the movement of tectonic plates in the Pacific. If they're right, then these giant underground blobs aren't just sitting there. They're almost alive in a way. They'd be constantly changing and shaping the surface of our planet. But why do they even matter? Because these weird underground structures may be shaping Earth's surface in ways we don't fully understand yet. You see, first, they might influence Earth's magnetic field. That's because they affect how heat moves through the mantle and core. They might also hold clues about the history of plate tectonics. Studying them could help us figure out when subduction began on Earth, whether it was over 4 billion years ago or much more recently. These guys might also be secret puppet masters behind volcanic activity. There's a theory that blazing hot rock from deep inside the Earth, the same kind that creates volcanic hotspots, might be rising straight from the giant blobs in the mantle. Some of the biggest volcanoes on Earth, including those in Hawaii, Iceland, and Yellowstone, sit directly above the suspected rising plumes from these blobs. If these blobs are fueling these volcanoes, then they could be responsible for shaping Earth's continents, climate, and even mass extinctions throughout history. And well, that's horrifying. That would mean that these giant structures might burst through Earth's crust one day, unleashing catastrophic supervolcanic eruptions, and these eruptions would last for millions of years. Beneath the Earth's surface also lies monsters unlike anything else on this planet – supervolcanoes. They're so massive, so destructive, and so rare that no human has ever witnessed one erupt. A regular volcanic eruption can be terrifying. lava spewing into the sky, ash choking the air, entire cities buried under fire and stone. But a supervolcano? Well, that's something else entirely. A supervolcano isn't just big, it's a category of its own. Their eruptions rip apart the Earth itself, creating massive craters called calderas. Some of them are over 30 miles wide. A regular volcanic eruption might spew out a few cubic miles of lava and ash. A supervolcano unleashes more than 240 cubic miles of material. That's enough to bury an entire continent in ash. An eruption like this would be newsworthy, to say the least. First, a wall of fire would blow up into the sky. Ash would block out the sun for years, dropping global temperatures. Entire countries could be buried under meters of ash, making farming impossible. Famine, extreme cold, and toxic air could wipe out entire civilizations. It wouldn't just be a local disaster, it would be global. In fact, two of the worst mass extinctions in Earth's history, where almost all life was wiped out, might have been caused by supervolcanoes, not asteroids. The biggest and most horrifying one was at the end of the Permian period. Literally, about 90% of all marine species and 70% of land species went poof. Scientists have counted about 20 supervolcanoes on Earth today. The most famous ones are Yellowstone in the US, Toba in Indonesia, and Topao in New Zealand. Now, the last time Yellowstone erupted was roughly 2 million years ago. It released almost 590 cubic miles of material, enough to bury a city like New York. That was just one of 3 Yellowstone supereruptions. The most recent supervolcano to erupt was Topao in New Zealand. This happened about 26,500 years ago. But supervolcanoes don't just destroy, they reshape the entire planet. About 74,000 years ago, the Toba supervolcano erupted in Indonesia. Some scientists believe it triggered a volcanic winter that lasted an entire decade. There are also theories that suggest that this eruption nearly wiped out early humans. It reduced their numbers to just a few thousand survivors, although that's just speculation. Either way, we know for sure that supervolcano eruptions have changed the course of history. So, how do we prepare for them if this could happen at any moment? Well, scientists monitor volcanoes constantly, looking for warning signs. It could be stuff like rising magma, ground swelling, earthquakes beneath a volcano, changes in gas emissions, and so on. The problem is that while we can predict short-term eruptions, the long-term ones are still a mystery. Yellowstone last erupted 630,000 years ago. It's literally overdue for another eruption already. But volcanoes don't work like clocks. Just because one erupted in the past doesn't mean it will definitely go wild again, and the time between eruptions could be random. Scientists think Yellowstone could erupt again, but it might be just a small lava flow instead of a super eruption. Are we ready for a super eruption if it happens? Probably not. Scientists say we're more prepared for an asteroid strike than a supervolcano eruption. When Hunga Tonga Hunga Ha'apai erupted in 2022, it cut off communications, caused tsunamis, and filled the sky with ash. And that was only a magnitude 5 eruption. A supervolcano would be orders of magnitude worse. So, good luck sleeping at night knowing these guys will erupt again. Maybe tomorrow, maybe in 100,000 years. Nah, don't lose sleep over it.
If you had landed on Earth a really long time ago, about 1.5 billion years in the past, you wouldn't have recognized our planet. At that time, all the land was stuck together in one giant supercontinent called Nuna, which was surrounded by an endless ocean. But if you had stuck around, you'd have witnessed a planetary-scale disaster, Nuna falling apart. But the most amazing thing is that apparently, when Nuna started breaking apart, it kicked off changes that made Earth a much better place for life. Scientists used to call this part of Earth's history the boring billion. It lasted from about 1.8 billion to 800 million years ago. Not much seemed to happen during that time, hence the name. No big climate changes, no bizarre life forms, and nothing very dramatic. Turns out the name isn't very fair. Things may have looked calm on the surface, but underneath, Earth was changing a lot. Continents were moving, splitting apart and coming back together. Two massive supercontinents, Nuna and later Rodinia, formed and broke up during this time. When Nuna began to break apart, huge cracks opened between the drifting land pieces. Water filled those spaces, creating shallow seas. Those seas were warmer, calmer, and had more oxygen than the deep oceans that existed before. And that might have changed everything. The new seas created friendlier conditions for life to grow and change. Scientists now think they may have helped early life become more complex. They looked back 1.8 billion years and rebuilt how Earth's tectonic plates moved over time. Plus, they tracked how carbon was stored inside the planet and released into the air. The researchers did this using a new advanced computer model that gave way more detail than they had ever had before. They found out that during the 350 million years of the so-called boring billion, the amount of shallow seas along the edges of continents doubled. Altogether, these coastlines stretched about 81,000 miles. That's more than 3 times around Earth at the equator. At the same time, subduction zones, places where one tectonic plate slides under another, actually got shorter as the continents shifted around. This is important because subduction zones are where a lot of volcanoes come from. When one plate sinks under another, seawater gets dragged deep into the Earth. That water helps rocks melt, creating magma. The magma rises, erupts as volcanoes, and releases gases like carbon dioxide into the atmosphere. So when there were fewer subduction zones, there were fewer volcanoes, and less carbon dioxide was pumped into the air. It went like this. The supercontinent Nuna broke apart, and it created lots of brand new ocean floors in young seas that didn't exist before. These new ocean floors pulled carbon dioxide out of the air. Seawater flowed into cracks in the ocean floor. When that happened, carbon got trapped in rocks, forming limestone. Over time, this process locked carbon away inside Earth instead of letting it stay in the atmosphere. With less carbon dioxide, Earth slowly cooled down. That cooler climate helped the new shallow seas become stable and rich in oxygen. Such calm, oxygen-filled environments are perfect for life to become more complex. Those huge shallow seas near the continents acted like safe nurseries for early life. They may have helped eukaryotes evolve faster. Eukaryotes are living things with complex cells. Cells that have parts inside them, like a nucleus that holds DNA. Every animal, plant, and fungus on Earth comes from these kinds of cells. So when eukaryotes appeared, it was a huge moment in the history of life. Scientists already knew that eukaryotes showed up during the boring billion because of fossils that are about 1 billion years old, but they didn't really know why this happened at that time. Now, scientists want to find better preserved early eukaryote fossils to learn exactly how complex life first evolved. Life on Earth started over 3 billion years ago. It began with tiny, simple microbes and slowly turned into a huge variety of living things. We still don't have a clear answer about how living things came out of that early primordial soup, but even though there's no final answer yet, scientists have come up with several theories to try to explain how life on Earth may have started. Some scientists think lightning helped start life on Earth. The idea is pretty simple. Lightning is a powerful spark, and sparks can cause chemical reactions. In a famous experiment from 1952, scientists showed that electric sparks could turn simple gases like water vapor and methane into amino acids and sugars, which are basic building blocks of life. This suggested that lightning in early Earth storms might have helped create the first life ingredients. But later research showed Earth's early air wasn't exactly like the experiment. Still, some scientists think volcanic clouds could have had the right gases and lots of lightning, making this process possible. Other experts think life may have started on clay. One researcher suggested that tiny clay crystals could grow and stick together in patterns. As they did, they could trap simple molecules and line them up in organized ways. Think of clay as a kind of early organizer. Today, DNA tells molecules how to line up and work together. But what if clay had been doing a similar job before DNA even existed? It could be helping molecules arrange themselves until they eventually learned to organize on their own. This idea was interesting and got a lot of attention, but most scientists don't fully accept it yet. Another popular theory is that life started at deep-sea vents on the ocean floor. These vents are cracks in Earth's crust where super hot water shoots out from deep inside the planet. As the water rises, it picks up important chemicals like carbon and hydrogen, which are key ingredients for life. The vents are full of tiny rock spaces where these chemicals could collect, mix, and react. The rocks may have helped speed up these reactions. Even today, deep-sea vents house rich ecosystems, even though it's dark there and the whole environment is kinda extreme. Scientists are still studying this idea. In 2019, researchers even created early life-like structures in lab conditions similar to these vents. Such an experiment showed that this theory could really work. Another idea is that life may have started under ice. Scientists believe Earth's oceans might have been covered in ice around 3 billion years ago. Sounds pretty severe, right? But the cold may have actually helped life get started. Many of the chemical building blocks of life, like simple amino acids, are more stable at low temperatures. In warmer water, these molecules break down quickly and are spread far apart. But when water freezes, it pushes those molecules together, increasing their concentration. This crowding makes chemical reactions more likely. So, let's say the molecules were packed closer together and were breaking down more slowly. In this case, they had more chances to link up and form more complex structures. Ice may have also acted like a protective blanket. It could shield the water from harmful ultraviolet radiation from the sun and from damage caused by meteor impacts. Another idea is that life didn't start on Earth at all. This theory is called panspermia, and it suggests that life came from space. Scientists know that big asteroid impacts can blast rocks off of planets. For example, rocks from Mars have been knocked into space before, and some of them ended up on Earth. Some researchers think tiny microbes might have survived inside space rocks during the journey. If that's true, life here could have started thanks to visitors from Mars, or some other cosmic world. Others go even further and suggest that life could have traveled on comets or space dust from completely different star systems, hitching a ride across the galaxy. At the same time, even if panspermia is real, it doesn't fully solve the mystery. It just moves the question somewhere else. Instead of asking how life began on Earth, we'd need to ask, how did life begin anywhere in the universe?
Okay, smarty pants, answer this one. Do you know what earthquake magnitudes actually feel like? Well, at magnitude 1, you wouldn't notice a thing. At 3, you might slosh your coffee if you're drinking. At 5, things can start to shake off shelves, and it definitely gets your heart racing. But at 7.5, that's when the ground itself rips, buildings sway, and whole streets can split. And now, scientists warn a fault we thought wasn't active anymore could unleash something that strong under a small sleepy town in Canada. Now, if you trace your finger across a map of northwestern Canada, you'll find Dawson City in the Yukon. It looks like a nice place to escape from civilization. After all, it only has about 1,600 residents. It's quiet, remote, and famous for its gold rush past. In the late 1890s, Dawson City ballooned into a boomtown almost overnight as prospectors chased gold. Today, the rush is long gone, but the town still looks the part. Wooden boardwalks and saloon-style facades give it the feel of a set straight out of a Western movie. Oh, and beneath all of that is a fracture in the Earth itself. Dawson City is located on top of what's known as the Tintina Fault. It's a massive crack in the Earth's crust that stretches for hundreds of miles toward Alaska. Until recently, scientists believed that this zone had been inactive for over 40 million years. But newer studies tell a different story. Just a quick reminder, faults are giant cracks when two slabs of Earth's crust meet. They're always trying to slide past each other, but their jagged edges catch and lock. Pressure builds for decades, continuously bending and straining the rock. Then, suddenly, the locked zone breaks, and the slabs slip into a new position in just seconds. That abrupt lurch releases all the stored energy, sending seismic waves racing outward. The ground-shaking consequence is called an earthquake. Scientists say the ground on each side of Titina has been trying to slide past itself for ages, but it's stuck. And now, that stuck zone has built up around 20 feet of strain. That's how far the land would shift sideways if it all gave at once. That's not just a small crack. That's straight up something from a disaster movie. If all that built-up tension snaps in one go, the result could be a magnitude 7.5 earthquake. How strong is that? Well, pretty strong. So, what happens during a big quake? The shaking can last up to 30 seconds or more, which is an eternity when the walls are swaying and the floor feels like it's rolling under your feet. If you're near the fault, things can get really scary. The ground doesn't just shake, it could take a big step sideways. This can lead to some renovations. Roads might get a new zigzag pattern, and unreinforced buildings could decide to do the twist. And if it happens in a Canadian winter, let's just say it could turn a simple power outage into a survival horror adventure. Being on soft soil is like sitting on wobbly jelly. It amplifies the shaking. Solid rock is a bit more stable. However, it's still dangerous. For example, in Mexico in 2003, a 7.5 quake damaged over 43,000 homes, buckled roads, and cut power for miles. In Sulawesi in 2018, the same magnitude not only leveled buildings, but triggered a tsunami and liquefaction. The whole neighborhood was swallowed as the ground turned to quicksand. Now here's something interesting. Most people don't think of Canada as an earthquake country, but it actually gets around 5,000 quakes a year. However, they're so small that you'd never feel them. The real hot spot is the West Coast, near British Columbia. That's where you hear people whisper about the infamous Big One. It refers to a future megathrust earthquake along the Cascadia subduction zone, a massive fault that runs for 600 miles just offshore. Unlike Tintina's sideways slip, Cascadia works by one tectonic plate shoving under another. For centuries, the North American plate has been bent upward like a spring as the Juan de Fuca plate has been diving below. When it finally snaps, that's a magnitude 9.0, more than 30 times stronger than a 7.5. We know it can happen because it already has. The last big one struck in 1700. It was so powerful, it didn't just shake the Pacific Northwest. It launched a tsunami across the ocean that smacked Japan, where villagers recorded an orphan wave with no local quake to explain it. Only later did scientists connect the dots. Now this brings us to the fact that despite all this, the size of the fault, the quiet buildup of strain, and the potential for a magnitude 7.5 earthquake, the Titina Fault isn't even listed on Canada's official seismic hazard map, at least for now. That means no warnings, no color-coded danger zones. And when a fault isn't on the map, nobody designs a building for it. There's no proper preparation. You don't build reinforced structures or have seismic codes, especially when people don't expect that the ground could split open. Now, to be honest, that's not someone's mistake. The fault just didn't show any signs of being active recently. And this part of Canada is really big, quiet, and doesn't have a lot of monitoring. Not until too long ago, people had thought of the Titina as just a geological oddity, something cool for looking at the past, but not really relevant for the future. For years, the Titina Fault flew under the radar, but that changed when researchers brought high-tech gear. They uncovered subtle but clear land shifts near Dawson City. They looked like scars on the landscape and pointed to past earthquakes, including one that pushed the land nearly 3,000 feet over millions of years. Now, interestingly, newer glacial features showed no signs of disruption, which means the last major quake probably happened right before the end of the last ice age. In geologic terms, that's pretty recent. When scientists lined up those land shifts with the ages of glaciers, the picture was clear. The Titina Fault isn't retired, it's just been on a really long coffee break, and now it's itching to clock back in. That's why researchers want it officially on Canada's seismic hazard map. Dawson City deserves more than a shrug emoji when the ground decides to stretch. The experts are basically playing detective with dirt. They're scanning forests and rivers for faint scars that past earthquakes tried to hide. They're digging trenches like archaeologists with a taste for chaos, flipping through the Earth's diary one muddy page at a time. Every crack, wrinkle, and layer adds to the story of when Titina last threw a tantrum and how loud the next one could be. It's pretty cool that satellites can literally track if one side of a valley is slowly creeping ahead of the other, like tectonic snail racing. The goal is to find out how often this fault snapped in the past, how much stress it's still holding on to today, and whether it's going to go off quietly or all at once. Finally, just because you know that plates are pushing against each other underneath, you still can't put a date on it. Long stretches of silence might mean the rocks are getting ready for something huge, or they could just be releasing stress in tiny ways that go unnoticed. Scientists can model possibilities, but no one has a countdown clock for the next rupture. The smartest mindset isn't prediction, it's preparation. You brace for the plausible, not the precise, because the Earth's schedule doesn't come with reminders. It turns out the Earth's crust is always fidgeting. It's just that our maps are a little behind on the gossip. A fault everyone thought was harmless might actually be sitting on a magnitude 7.5 size secret. But don't worry, this isn't a cue to panic. It's a cue to get smart. Better data, sturdier buildings, and a few just-in-case habits. When the ground finally decides to settle its debt, what really matters isn't whether Dawson City feels the shake. It's whether everyone's prepared enough to turn a potential disaster into just a real wild story to tell later. Hey, have you ever been in an earthquake? I have. Tell me your story in the comments.
Imagine standing in a quiet northern town, surrounded by mountains and forests, when the ground beneath your feet suddenly shifts with the force of a freight train. That's not a movie scene. It's a very real possibility for the people living in Dawson City, Canada. Hidden beneath the tranquil Yukon landscape lies a geological giant, the Titina Fault. For more than 12,000 years, it has been silent, but new research suggests it might be ready to wake up in a spectacular and dangerous way. Stretching over 1,000 kilometers from the Yukon into Alaska, the Titina Fault is like a massive crack in Earth's crust, a boundary where colossal slabs of rock slowly grind past each other. On the surface, it looks harmless, just rugged terrain, rivers, and forests. But deep underground, strain is quietly building, like a spring being wound tighter and tighter. Theron Findlay, a geologist from the University of Victoria, and his team decided to take a closer look at a section of this fault near Dawson City. This wasn't just a casual inspection. They used cutting-edge tools like high-resolution satellite images, aerial surveys, and LiDAR, a laser-based scanning method that can reveal subtle changes in the ground's shape. What they found was unsettling. In one location, the ground was visibly displaced by an astonishing 1,000 meters, evidence of a long series of powerful earthquakes millions of years ago. In another area, they spotted a smaller but still significant offset of about 75 meters, likely caused by more recent quakes, roughly 132,000 years ago. Since then, nothing major. At least, nothing visible. And that's exactly the problem. When a fault line hasn't released energy for thousands of years, it doesn't mean it's safe. Quite the opposite. It could mean that massive pressure has been silently accumulating. Based on their calculations, the Titina Fault has been moving at a slow creep of up to 0.8 millimeters per year. Over 12,000 years, that adds up to a staggering 6 meters of potential movement waiting to be unleashed. If that strain were to suddenly break free, the resulting earthquake could be bigger than magnitude 7.5. For context, that's in the same league as some of the most destructive quakes in history, like the 1976 Tangshan earthquake in China, or the 2010 Haiti disaster. While the Yukon isn't densely populated, the impact could still be devastating, damaging highways, collapsed buildings, landslides cutting off communities, and potentially loss of life. The scientists can't say when it will happen. Earthquakes don't work on a schedule, and predicting the exact moment of rupture is one of geology's greatest challenges. What they do know is that the Tintina Fault is in what's called a late stage of its seismic cycle, a point where the risk of a major quake is higher. For the people of Dawson City and surrounding areas, this means living with a quiet but ever-present threat. Emergency planners might advise residents to have evacuation routes, survival kits, and backup communication plans. But in the end, this is a reminder of a simple truth. Earth is never truly still. Even in the most peaceful landscapes, immense forces are always at work, reshaping the planet in ways we can't always see, until the day they reveal themselves with a violent jolt. Yet, the story of the Tintina Fault is more than a warning. It's a glimpse into how Earth stores and releases its pent-up energy. Each millimeter of annual movement is like another twist of a key in a lock. At some point, the lock will turn, and when it does, the release will be sudden and powerful. LiDAR images reveal ancient scars across the land, subtle to the untrained eye, but obvious to scientists. These are the footprints of past disasters, frozen in the ground like a history book carved by nature. Finley and his colleagues believe the region's seismic silence has lulled people into a false sense of security. A place can be both beautiful and dangerous, and the Yukon is a perfect example. Visitors come for the sweeping vistas and endless wilderness, rarely realizing that deep beneath their hiking trails and scenic roads, forces are shifting that could change the landscape overnight. This hidden drama plays out all over the world. Fault lines in California, Turkey, Japan, and beyond all share one trait. They eventually break. The question is never if, but when. The Tintina Fault just happens to be one of the quieter players, which in geological terms can be far more ominous than the noisy ones. And so, the clock ticks, silently, in the frozen north, counting down to a moment no one can see coming.
The floor is lava. Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction. and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first.
Consider South America and Africa. Don't they kind of look like they fit together, like puzzle pieces? Well, they actually did. But about 130 million years ago, South America was like, bye, and slowly started drifting away. These days, it's around 1,800 miles from Africa, and it's still on the move. Every year, the continent shifts a little more toward the Pacific Ocean. So, how's that even happening? Tectonic plates are constantly moving. That's what makes the Earth's surface shift over time, going from this to what we see today. But those movements happen so slowly that you and I can't see them go. So, no, Brazilians or Chileans aren't out there feeling their continent inching westward. But the numbers don't lie. South America is moving, and apparently all it wants is to get as far away as possible from this massive underwater mountain range called the Mid-Atlantic Ridge. But what exactly is pushing the land toward the Pacific Ocean? It is the heat inside our planet. Way, way down beneath the ocean, there are cracks in the Earth's crust, and magma, super hot melted rock, rises up through those cracks. When that happens, the magma cools and hardens into solid rock. Over time, this process might build underwater mountains, like the Mid-Atlantic Ridge. And as more new crust forms, it begins to push the older crust out of the way. In the process, tectonic plates and the continents riding on top of them get pushed along. Now, on the other side of South America, over by the Pacific, there is the Nazca Plate. It's heavier and it's moving eastward. Since it is denser, it is sliding underneath the South American Plate. This entire process is called subduction, and it's happening at a rate of about 3 inches per year. By the way, the collision between these two plates is what's behind all those breathtaking volcanoes scattered throughout the Andes, and it's also making the continent move. So, if everything goes according to plan, projections show that South America will end up more centered in the Pacific Ocean in the future. But some models suggest something way crazier. Before we get into that, though, we need to clear something up. Why on earth isn't Africa following in South America's footsteps? I mean, shouldn't it be drifting west too? Well, not quite. Africa is doing its own thing, because it sits on the African Plate. So the Mid-Atlantic Ridge is located between those two continents, and just like it pushes the South American Plate, it also pushes the African Plate, but in the opposite direction. It's like this ridge is trying to split up two ex-besties, But there's more. Africa is also being influenced by the East African Rift. That's one of those massive cracks we talked about earlier, but it's happening on land, which makes it extra dramatic. This is what's causing the continent to slowly split apart. It's a long story, but let's just say the rift is pulling Africa in more directions than South America ever had to deal with. Okay, now it is finally time to talk about that crazier thing that might happen to South America and everything around it in the future. Theory number 1. It could break away from North America. I know, super dramatic, but don't panic. We're talking hundreds of millions of years from now, and I won't be around. You see, both continents are moving in the same general direction, but at different speeds. The North American plate is cruising along at about 1 inch per year, while South America is moving a bit faster. So even though they're heading the same way, they are not keeping pace. Over time, as the Atlantic Ocean continues to widen and the Pacific keeps shrinking, all this tectonic movement could eventually pull the Americas apart. Theory number 2. Marine life could go through some major changes. Right now, the Americas act as kind of a giant wall between the Atlantic and Pacific Oceans. Because of that, sea animals have evolved differently on each side. Take the green sea turtle, for example. The ones living in the Atlantic tend to be bigger and lighter in color. Meanwhile, their Pacific cousins are usually smaller and darker. But if, one day, there is no land blocking these two populations from mixing, they would end up with brand new migration routes, new nesting spots, and a lot more overlap in their territories. Now, multiply that scenario by hundreds of other species, and things could really get shaken up. We're talking about new interactions, unexpected competition, and maybe even the rise of entirely new species. Alright, theory number 3. America might meet Africa again. Right now, the Mid-Atlantic Ridge is busy creating a new seafloor, and because of that, the Atlantic Ocean is slowly getting wider. But in about 125 million years, scientists believe that process could come to a stop. Instead of the seafloor spreading apart, the ocean floor might start getting pulled under the continents. When that happens, the Atlantic will stop growing and start shrinking. And the water section between South America and Africa is likely to be the first part pulled beneath the land. That means the Americas and Africa could meet again. And when that happens, border countries could turn into super shaky places, with earthquakes happening all the time and brand new volcanoes popping up left and right. The eastern United States would no longer be known for the peaceful green slopes of the Appalachians, but for snow-covered giants that occasionally spew lava and ash, more like the Cascade Range out west. Countries would end up with totally new neighbors. Brazil might line up with Nigeria and Cameroon. Uruguay could be sitting right next to Angola, and Argentina might be sharing a border with South Africa. So if these two continents really do merge, how intense would that be? Well, for starters, this new supercontinent would instantly become the biggest one on Earth, about 1.5 times the size of Asia. And chances are, a brand new mountain range would form right where the continents meet, creating a natural border between nations. Being part of the same massive continent could make a lot of things way easier. For one, tourism could totally take off. People traveling between countries by land without needing pricey plane tickets could be a game changer. But it wouldn't stop there. Other types of economic activity could get a major boost too. Now on one side we have South America, which already produces and sells a wide variety of foods, from wheat to bananas, beef, cocoa, soybeans, hey, you name it. On the other side, there is Africa, exporting things like textiles and clothing. That alone would make them a super powerful bloc when it comes to trading raw goods. But can you name another important thing these two continents have in common? Yep, petroleum. Countries in South America, like Brazil, Venezuela, and Colombia, are major oil exporters. And over in Africa, you've got Nigeria, Algeria, and Libya doing the same. Now, can you see just how powerful that kind of union could be? Meanwhile, let's talk about animals. These two massive lands coming together could lead us to wild meetups, like a capybara sharing space with a Nile crocodile, or a sloth seeing a hyena from the top of a tree. This could even lead to new animal hybrids showing up, like a cabby crocodile or a sloth hyena. Okay, those weren't the cleverest names, and honestly, these animals wouldn't be able to mate or even wouldn't want to. But you get the point, right? It's not all positive, unfortunately. New species showing up could become predators, competitors, or even parasites to the native plants and animals. It would take a long time for things to settle into a new balance in those border regions. But honestly, no one really knows how long it would take. The only thing I do know is neither of us will be around to see it, which is okay.
At first, researchers thought their cameras were glitching. It was the only possible thing that could explain the weird view in front of them. Scalding water was blasting upward while cool methane was fizzing out right beside it. Such a combo wasn't supposed to even exist, but it did. Scientists were exploring the ocean floor near Papua New Guinea when they stumbled across a weird deep-sea hotspot. It wasn't like any other hotspot. There, super hot and cool methane-packed gas were bubbling out almost side by side. This almost never happens in nature, so the researchers were pretty shocked. They were cruising around with a deep-diving robot, the Rove Keel 6000, poking around underwater volcanoes in a remote island chain. These volcanoes hide all sorts of strange features, but nobody expected to find a full-on hydrothermal vent just tucked down there. Plus, other research trips had passed through the area before and missed it completely. This time, the robot's cameras lit up the seafloor and revealed a bizarre view: boiling vents and cold gas seeping out of the seabed. They were practically touching each other. As you understand, normally these two things show up in totally different places. Hot hydrothermal vents form when underground water gets cooked by magma and shoots upward, carrying minerals with it. Methane seeps, on the other hand, come from cold, mushy layers of sediment packed with old organic matter. This stuff slowly breaks down and leaks out as gas. But at this spot, the geology created a perfect mashup. Under the volcano sits a thick layer of organic-rich sediment. Magma creeping up from below heats these sediments, but at the same time, it also heats mineral-rich water deeper down. So you get two very different fluids: blazing hot vent water and cooler methane gas. Still, both are traveling upward through the same cracks in the seafloor. When they reach the surface, they escape just inches apart. So you end up with this bizarre little neighborhood where boiling mineral water and chilly methane bubbles are hanging out like best buddies. To ocean scientists, this is like discovering a unicorn that can also fly. It's weird, rare, and super exciting. An even more exciting thing is that right next to those weird hot and cold vents, an entire mini-world of creatures has taken over the rocks. The place is packed with huge clusters of deep-sea mussels, long tube worms, little shrimp, and amphipods crawling everywhere, and even bright purple sea cucumbers sitting out in the open. The animals are so crowded together that it's hard to even see the rock underneath. Scientists are pretty sure some of these creatures are totally new to science, but they need a special trip just to identify everything living there. The strange mix of hot fluids and methane-heavy gas also changes the rocks themselves. The methane down there is super concentrated, while hot water coming from deeper inside the volcano brings chemicals with it. Together, they create unusual reactions underground. Because of this, metals like gold and silver have built up in the rocks, along with elements like arsenic, antimony, and mercury. It's like a chemical time capsule. The rocks show signs of an older, super hot phase when precious metals were forming. Today, the vents are cooler, but still active. Now, even though this deep sea area is rare and full of life, it isn't safe. Mining already happens nearby, and waste from the huge gold mine on Lahir gets dumped into the ocean. On top of that, companies have licenses to explore the seafloor for minerals and gas. All of this puts the fragile vent community in danger because many of the animals here can only survive in these exact conditions.
So scientists are urging for more research and strong protection plans before this one-of-a-kind ecosystem is damaged beyond repair. This underwater treasure needs to be saved before industry wipes it out. This discovery, though, isn't the only unique ecosystem we've ever found. In January 2025, a gigantic iceberg named A84, roughly the size of Chicago, cracked off Antarctica's George VI ice shelf. This ice shelf is enormous on its own, stretching about 280 miles from end to end and about 820 feet thick. During the Antarctic summer, which is November through late February, the top of the ice shelf melts and forms long, skinny pools called ribbon lakes. They got that name because they really do look like giant icy ribbons stretched across the surface. Once A84 broke free and drifted off, it exposed part of the seafloor that had been sealed away under the ice for who knows how long. It was a place absolutely nobody had seen before. A research team aboard the ship Falkor 2 happened to be in the Bellingshausen Sea at the time. As soon as they got word about the iceberg breaking loose, they ditched their original plan. This was basically the deep-sea version of flipping over a huge rock in the woods just to see what's living underneath it. For 8 days, the scientists sent down their underwater robot, Sebastian, and explored depths of more than 4,200 feet. Down in that freezing darkness, they discovered a hidden ecosystem packed with life. Huge corals and sponges formed underwater neighborhoods that were absolutely crawling with creatures. They were not just barely alive, they were thriving. So yeah, the scientists expected to find something down there, but they definitely didn't hope to spot a full-on underwater city of ancient life. There were sea anemones that looked like tiny fluffy trees, sea spiders marching around like creatures from other planets, ice fish, octopuses, and a whole mix of other animals. The entire expedition was live-streamed to researchers around the world. By the way, the recordings are still publicly available if you're interested. Even cooler, the researchers think some of the creatures they saw might actually be brand new species. That's right, genuinely new species in Antarctica in 2025. A few might live only in this one area, and that makes sense because Antarctica is basically its own isolated planet. It's surrounded by the Antarctic Circumpolar Current, which acts like a giant watery moat that has kept the continent cut off from the rest of the world for millions of years. But even if the new species ended up being known ones, the scientists still found some extremely rare animals, like tiny snails, bristly worms, aka polychaetes, little crustaceans, and even the mysterious phantom jellyfish, which already looks like something from outer space. The scientific name for the phantom jelly is Stygiomedusa gigantea, but no one really needs that mouthful, so giant phantom jelly is fine. This thing is massive. Its bell, the umbrella-shaped top, can be more than 3 feet wide. It also has 4 long ribbon-like arms that can stretch up to 33 feet. That's the length of a school bus. Actually, the first one was collected in 1899, but scientists didn't even realize it was a completely new kind of jellyfish until 60 years later. Its body is mostly see-through with a ghostly purple tint, and instead of normal tentacles, it uses those big flowing arms to grab prey and feed itself. Even though jellyfish don't have brains, the way this giant phantom jelly moved caught scientists off guard. It seemed to steer its long arms with surprising control, especially when it drifted through tight spaces near the seafloor. It looked cautious and almost intentional, which is kinda unsettling. Another maybe kinda sorta smart creature lurking in the dark ocean? Great. The researchers also found bristleworms. Officially, they're called polychaetes, but bristleworms sounds way more fun. These worms are common in cold, deep oceans and come in tons of shapes and sizes. Their bodies are made of segments lined with tiny bristles that help them crawl, sense the environment, and defend themselves. One standout is the Antarctic scale worm, which has shiny golden bristles that make it look surprisingly fancy for a creature living in freezing darkness. So, as you see, there are still tons of places and things on Earth that don't seem real or aren't even supposed to exist. And even with our level of technology, we're unlikely to figure out all the wonders the world has to offer in the near future.
Frankenstein, unreasonably cold weather, and tons of lava. What do these things have in common? They all trace their origins back to Mount Tambora. This volcano in Indonesia had such a massive impact that the aftermath could be felt in Switzerland even a year later. And these spots are thousands of miles apart. Soon, we might be facing something similar again. Stick around because I'm about to reveal the exact spot where the next eruption is expected to happen in 2025. Back in 1815, Mount Tambora erupted with unprecedented force, sending a colossal cloud of fine particles into the atmosphere. This cloud reflected sunlight, leading to global cooling and even the year without a summer in 1816. Temperatures plummeted, crops failed, and families worldwide faced food shortages, compounded by various health issues. Fun fact: Frankenstein appeared because of abnormally cold weather in the summer of 1816. The author got stuck indoors in Switzerland and wrote this story to pass the time. But that is the only positive aftermath. In England and Ireland, people struggled to find food. The crops were too bad that year, and this year without summer cost them lives, all because of the eruption in Indonesia. While many other volcanoes have erupted since then, none have had consequences as dramatic as Tambora. However, climate professor Marcus Stoffel from the University of Geneva believes potential serious eruptions aren't just a matter of luck, it's only a matter of time. So it's up to us. We can sit back and wait for the inevitable, or we can start preparing today. This future eruption will happen in a world that's vastly different from the one in 1815. Not only is our planet more densely populated now, but we've also experienced irreversible changes that affect our daily lives. Now, if you think volcanoes are always the bad guys, think again. They've actually played a crucial role in shaping our planet. They help with land formation, atmospheric development, and climate modulation. Just look at Yellowstone, for example. When thick lava oozed to the surface, it spread across the landscape and transformed the area forever. When volcanoes blow their tops, they release a mix of lava, ash, and gases, including carbon dioxide. But don't worry, compared to the emissions from fossil fuels, the amount from volcanoes is pretty tiny. What scientists are really keeping an eye on is sulfur dioxide, because it can have a big impact on our climate. When a major volcanic eruption happens, it can send sulfur dioxide soaring into the stratosphere, which is about 7 miles up in the atmosphere. Once there, it transforms into tiny aerosol particles that scatter sunlight, helping to cool the planet. This cooling effect isn't immediate though. Those particles can hang around for a couple of years and even circulate all around the globe. Nowadays, we've got special equipment to monitor sulfur dioxide emissions from space. Take Mount Pinatubo in the Philippines. During its eruption in 1991, it released around 15 million tons of sulfur dioxide. Now, while that's a lot, it wasn't quite as massive as the eruption of Tambora. Still, Pinatubo managed to lower global temperatures by about 0.5 degrees Celsius for several years. Tambora, on the other hand, dropped average global temperatures by about 1 degree Fahrenheit. I know what you might be thinking. That's not much, but trust me, it makes a difference. If the planet warms up by just 1 degree Fahrenheit, it could really mess with sea levels. Experts think we might see a rise of up to 8 inches by the end of this century. This could wipe out a lot of farmland and coastal habitats, which would be a huge blow to many communities. So maybe a volcano eruption that can cool off the planet is like a natural mechanism helping us out? Not exactly. While it does cool the planet off, don't get tricked into thinking it's the kind of coolness our planet needs. Such temperature shifts can severely mess up with the crops, like they did in 1816. There's also evidence that major eruptions can disrupt rainfall patterns, leading to drier conditions in monsoon regions across Africa and Asia. You see, the summer monsoon relies on the temperature difference between land and ocean, which can be altered by volcanic activity. Interestingly, a warmer climate may enhance the cooling effects of volcanic eruptions. Experts explain that the formation and movement of aerosol particles depend on climate conditions. As global temperatures rise, faster air circulation can lead to smaller aerosol particles, which are more effective at scattering sunlight and thereby intensifying the cooling effect. Oceans also contribute to this dynamic. A warming ocean surface creates a stratified layer, hindering the mixing of warm and cold water, which could mean that volcanic eruptions primarily cool the upper ocean layer and the atmosphere above it, according to Stoffel. Moreover, climate change may influence volcanic systems directly. The melting of ice can trigger more eruptions by reducing the pressure that allows magma to ascend more easily. Additionally, increased rainfall associated with climate change can seep into the ground and interact with magma, potentially sparking eruptions. While the prospect of a cooling period due to a volcanic eruption might seem beneficial amid climate change, scientists warn that the effects could be dire. The immediate consequences could be severe, particularly for the estimated 800 million individuals residing near active volcanoes. A major eruption could devastate entire cities. For example, Campi Flegrei, located near Naples, Italy, is showing signs of increased activity and threatens the lives of about 1 million people. Now, if you're from Oregon, beware, as experts say this state might experience volcano eruptions. Are you scared? Don't be. It's actually not as scary as it seems. Let me explain why. There are more than 80 volcanoes in Oregon, but we're not interested in a single one of them because it's an underwater volcano that is likely to erupt in 2025. Axial Seamount is the most active volcano in the Pacific Northwest, yet it remains largely unknown to the public due to its location approximately 300 miles offshore and nearly a mile beneath the ocean's surface. While its upcoming eruption is expected to pose no threat of a tsunami or significant land-based earthquakes because of its depth and distance from the Cascadia Fault, the data gathered from studying its eruptions can enhance our monitoring of potentially more hazardous volcanoes. Let's call it a friendly eruption, shall we? In reality, predicting eruptions is a complex endeavor. We often encounter alarming headlines, such as, "Yellowstone is about to erupt." Should we take these claims seriously? Not really. Yes, Yellowstone sits atop an active supervolcano that has experienced 3 major explosive eruptions in the past 2.1 million years. The last eruption occurred approximately 70,000 years ago, with the most significant explosion taking place around 631,000 years ago, forming the massive Yellowstone caldera. Naturally, many people are curious about whether Yellowstone will erupt again and when that might happen. Fortunately, scientists are employing new techniques to delve into these questions. A recent study suggests that Yellowstone is unlikely to experience another major eruption anytime soon. The reason is that the magma beneath the park is divided into a network of separate chambers. While there is a substantial amount of magma present, it's not sufficiently interconnected to support an eruption. Previous studies proposed that the existence of a massive layer of magma beneath Yellowstone, but these latest findings change that notion. To gain a clearer understanding of the subterranean dynamics, researchers utilized a technique called magnetotellurics, which employs Earth's natural electromagnetic fields rather than seismic waves. Since magma is a good conductor of electricity, this method is particularly effective for mapping molten rock and comprehending underground activity in volcanically active regions. By using magnetotellurics, scientists created a detailed map of the magma under Yellowstone, enabling them to make more informed predictions about future eruptions. But what will happen if an eruption similar to Mount Tambora occurs? By and large, there will be huge climate chaos. Yeah, the best scientists are looking for the solution should it really happen, but they don't have it yet. So technically, we're not ready for the second Mount Tambora. But for now, we're pretty much safe. No major eruptions are predicted. Whew!
Oh boy, scientists predict a volcanic eruption that is likely to be one of the most destructive in the history of our species. There's a 1 in 6 chance of it happening in this century, and it could seriously change the climate even more and put millions of lives in danger. Back in January 2022, the Hunga Tonga Hunga Ha'apai volcano erupted in the South Pacific Ocean, creating a huge explosion. It sent tsunamis all the way to Japan, North America, and South America. Tonga itself was hit hard, with damage costing nearly 20% of the country's entire economy. Now, researchers at the Niels Bohr Institute in Copenhagen have studied ice samples from Greenland and Antarctica, and their findings are worrying, predicting potential global volcanic disaster. They say there's a real chance of a much bigger eruption, a whopping 10 to 100 times larger than Tonga's. In the past, eruptions this size used to change the climate and even cause civilizations to collapse. Despite future volcanic eruption risks, experts say the world isn't prepared at all. Michael Cassidy, a volcanologist from the University of Birmingham, warns that no sufficient effort is made to handle a disaster like this. He says that NASA and other space agencies spend billions on asteroid defense. At the same time, a volcanic supereruption is way more likely than an asteroid impact. And right now, there's no global plan for dealing with a massive eruption, even though it's likely to be far more destructive. The last magnitude 7 eruption happened in 1815 at Mount Tambora in Indonesia. Then, thousands of people lost their lives in just a few days. The disaster also disrupted weather and caused food shortages worldwide, affecting millions. That eruption was the biggest in recorded history. It blasted a massive cloud of particles into the sky. Those particles blocked sunlight, cooled the planet, and caused worldwide chaos. The year after the eruption became known as the Year Without a Summer. Temperatures plummeted, crops failed, famine spread, and a cholera pandemic broke out, leading to tens of thousands of lost lives. A shocking fact, the eruption may have even inspired Mary Shelley to write Frankenstein while stuck indoors during the unusually cold summer of 1816 in Switzerland. Now, since then, many volcanoes have erupted, but none have matched Tambora's scale. Now, over 200 years later, scientists warn that there's a new supervolcano threat. Another massive eruption could be on the way, and the world might not be ready for it. So, while scientists seriously discuss the likelihood of the next volcanic eruption, experts are calling for urgent action to prepare before it's too late. So, the thing is, a massive volcanic eruption today could be even more devastating than the Year Without a Summer. Unlike back then, we're already dealing with all kinds of weather changes and a more fragile global system, which could make the effects even worse. Dr. Michael Rampino, a geological scientist, warns that the world is more unstable now, and it means that a modern-day mega-eruption could have even more severe consequences. But this time, greenhouse gases from fossil fuels may make the aftermath of such an eruption even colder instead of warmer. So we're talking about volcanic activity endangering humanity. Dr. Thomas Aubrey, a volcanologist, found that in a hotter, more turbulent atmosphere, the sulfur dioxide gas released by a volcanic eruption would spread faster and farther than in the past. This gas forms sulfate aerosols, which reflect sunlight and cause global cooling. Because these tiny particles would be more evenly distributed, they'd have a stronger cooling effect than in 1815. Another atmospheric scientist at Cambridge explains that the size of these airborne particles matters. It affects how they absorb sunlight, and in a future warmer climate, an eruption could make the surface cooling stronger by 15%. At the same time, there are still many unknowns. Scientists from the University of Geneva say that we're only beginning to understand the full impacts of such an event. It's also difficult to precisely estimate future volcanic eruption risks, since we have very little data on older eruptions. So, to understand past volcanic activity, researchers analyze ice cores from Greenland and Antarctica, as well as ancient tree rings. Those act as historical records of weather changes. These measurements suggest that several eruptions in the past few thousand years temporarily cooled the planet by about 2 to 2.5 degrees Fahrenheit. One of the most catastrophic examples is the 1257 Somalis eruption in Indonesia, which was so powerful that it likely triggered the Little Ice Age. It was a period of global cooling that lasted for hundreds of years. More recently, the 1991 Mount Pinatubo eruption in the Philippines slightly cooled Earth for a few years. Because this eruption happened in the satellite era, scientists were able to measure exactly how much sulfur dioxide was released and how it affected the atmosphere. But even with modern tools like satellites and seismic instruments, scientists still have difficult times forecasting the next big volcanic eruption. Luckily, even though we can't predict the exact timing, we can study worst-case scenarios to help authorities prepare. This includes creating evacuation plans and stockpiling food in case of global crop failures caused by volcanic cooling. The changes in weather patterns might make volcanoes more active. Melting glaciers can reduce pressure on underground magma, which will increase the chances of an eruption. Plus, more extreme rainfall, which is becoming more and more common, can seep into volcanic cracks and cause powerful steam-driven explosions. It can affect both active and dormant volcanoes. Because of these risks, researchers are now mapping volcanoes that are the most vulnerable to climate change. Their studies show that the highest supervolcano threat comes from such areas as Iceland, Chile, and Indonesia. Those are places where glaciers are melting quickly or rainfall is increasing dramatically. A 2022 study found that 716 volcanoes worldwide, that's about 58% of all known active above-ground volcanoes, could be triggered by extreme rainfall, increasing the likelihood of another mini ice age. Now let's get back to that Hunga Tonga Hunga Ha'apai eruption that occurred on January 15, 2022. Scientists have confirmed that it created the highest plume ever recorded. The volcano, located underwater in the South Pacific, sent an ash cloud 187,000 feet high. That's higher than any previously recorded eruption. What makes this eruption even more remarkable is that it was the first to ever reach the mesosphere. It's the third layer of Earth's atmosphere. The mesosphere begins at about 160,000 feet above Earth, where meteors start burning up and creating shooting stars. To measure the plume's height, researchers from the University of Oxford and RAL Space used data from 3 geostationary weather satellites. Before this, the record for the highest volcanic plume was held by Mount Pinatubo's 1991 eruption in the Philippines, which reached 131,000 feet high. Interestingly, this kind of measurement was only possible thanks to modern satellite technology, and a decade ago, no one would have been able to do this. Another volcano we should mention in relation to a potential global volcanic disaster is located on Iceland's Reykjanes Peninsula. Its latest eruption happened in November of 2024, leading to evacuations in nearby areas. The eruption began just after 11 p.m. with little warning. The volcano released orange lava from a nearly 2-mile-long fissure. Authorities ordered evacuations for about 50 homes and guests staying at the Blue Lagoon Spa Resort, a popular tourist destination southwest of Reykjavik. While air travel was not affected, officials still warned of potentially dangerous gas emissions spreading across parts of the peninsula, including the nearby town of Grindavik. Grindavik, home to 3,800 residents, has repeatedly witnessed volcanic activity, and past eruptions even damaged its infrastructure and forced evacuations. For example, in August 2024, a 2.5-mile-long crack opened at the Sunthunkangigar crater near Grindavik. It led authorities declaring a state of emergency as lava flowed in multiple directions. Fortunately, Iceland's meteorological office reported that the latest eruption was significantly smaller than the one in August. Geophysics experts conducted aerial surveys and figured out that the situation appeared less intense than the previous eruptions. These days, Grindavik is not at risk, but the possibility of further developments cannot be ruled out. Scientists predict more volcanic eruptions.